Assalamualaikum, my name is Nufata Diana binti Mak Khairul Anwar. My case ID CD200-209 from section 1. Today I would like to present a report project titled Transmission Shaft. Right, a transmission shaft is a circular section rotating motion part that supports and transmits power using transmission elements such as gears, pulleys, and sprockets. Right, shafts are always tapped with the greatest diameter in the middle and the smallest at the ends where bearings are installed. Steps are used to place transmissions components such as gears, pulleys, and bearing by acting as shoulders. Even though they are all include the transmission of power, motion, and torque, shafts are given different names in different applications. Right, classification of transmission shaft. Number 1 is axle. Number 2 is spindle. Number 3 is counter shaft. Number 4 is jack shaft. And the 5th is a line shaft. Alright, there are 5 types of problem in our real life. Number 1 is deflection of beam, which is Taiwan bridge. Horizontal beams are supported at each end by substructure sections, and they can be either simply supported or continuous when joined over 2 or more spans. In the first beam bridge, simple logs set over streams and other similar structures. The bridge vertical force is produced to shear and flexural stress in the beam, which is transmitted to both tight substructures. Right, the most often used materials are steels, concrete, and wood. Alright, the second problem is torsion force, which is twisting cloth. Torsion force is the force that is created when one end of an object is twisted while the other end is rotated in the opposite direction or held in a fixed position. The type of the object determines how it reacts to torsion force. The brittle item, for example, breaks down. The elastic object reverts to its previous shape once the force is released, and the flexible object deforms, among other things. The twisting or turning of an object is caused by the torque force. On the other hand, the object will only be able to move in a straight line if torque and torsion were absent. Right, the next problem is bending moment and shear diagram, which is skateboards. Skateboards are a type of athletic equipment that may be used for both transportation and enjoyment. The deck or the rail board, the truck, which is a metal component that secures the wheels to the deck, and the wheels make up a complete skateboard. The deck is the skateboard's main body. The dimensions and strengths of most skateboards are equivalent. Longboards or cruisers are the 2 types of skateboards. Longboards are designed for street riding, whereas cruisers are designed for tricks. The next one is torsion force in bearing failure. In machine, smooth running bearings keep manufacturing operations flowing, even though they bear the weight of the body and the manufacturing burden. They are typically overlooked parts of the process. Bearings are typically unnoticed until there is a bearing failure in the facility. Bearing life is defined as the number of hours a bearing may operate before the first signs of metal fatigue develop in the rings or rolling section. Bearing failure will be the source of many motor troubles. Loud bearings are typically caused by the motor vibrations. Last but not least The last problem, which is torsion force in transmission shaft. The transmission shaft is a rotating and torque transmitting mechanical component. It's designed to link other drivetrain components that may not be directly linked to distance or the need for relative movement. They must be able to withstand the force without adding excessive weight, which will increase their inertia. Drive shaft might include one or more universal joints, jaw couplings, or rack joints, as well as a spline joint or prismatic joint to detect changes in alignment and distance between the driving and driven components. Alright, counter and line shaft, for example, transmit electricity from the source to the machinery that absorbs it. Therefore, shafts are an essential component of machine.
Assalamualaikum warahmatullahi wabarakatuh. My name is Arif Hakimi bin Nazaki. My matric number is CD200079. I will present for the problem statement and objective. First, we go for the problem statement. Shaft is one of the important components in a machine. Shaft is one of the main reasons for the machine to work. Shaft is used to transmit power from one member to another member. When a tangential force is acting on the shaft, a turning moment is set up. This makes the shaft to rotate for transmitting power from one shaft to another shaft. The shaft process can be many problems when the shaft is working. The example of shaft problem is overload failure, fatigue failure, and other problems. Some of the shaft failure is caused by the diameter of the shaft is not suitable for the process. Shaft size is detected by the torque. The way to design a shaft is to calculate the minimum diameter needed to control torsional deflection during the service. Therefore, the diameter of the shaft needs to make sure that the diameter is suitable with the torque, so there will no problem for the machine to run the process. Next, we go for the objective. The objective of the project is to study and analyze the diameter of shaft to make sure it is suitable with the torque using the solid mechanic principle of torsion. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. Today I want to talk and discuss about design analysis. The material of shaft we use is hot rolling is commonly used to create shaft which are then control or turn and ground precise. We choose to install rotor on the shaft because we studying the other members to apply on the shaft. So the diagram below shows a shaft model that has been attained by the addition of two rotor with suitable spacing. This is because we change the speed and diameter of the shaft. So this is the diagram after modification. We added two rotor on the shaft to improving the model. So the diameter of the shaft after modification is larger than before modification. It is because according to the calculation. So the greater the diameter of the shaft, the greater the force that can be applied to it. With this new advice, the new shaft will become greater, able to exert greater force by raising the power and decreasing the torque of the shaft. So the power and speed are the most important transmission shaft performance specification. As a result, the shaft material and cross-section must be chosen to match performance requirement while not exceeding the permit shear stress. So this is calculation before modification. Given G equal 80 gigapascal, torque max equal 55 megapascal, and angle less than 1.8 degree. Torsion AB equal 100 Nm, torsion BC equal 250 Nm, torsion CD equal 400 Nm, and torsion DE equal 200 Nm. We use equation for formula torque equal TC over J and equal to T over pi C power of 3. C power of 3 we calculate, we get 1.15 exponent negative 5 meter. So we get C equal 22.63 millimeter. So angle PE over A equal 1.8 degree. We convert to radian, we get 31.42 exponent negative 3 radian. So angle PE over D equal 120 over GJ. Angle PD over C we get 116 over GJ. Angle PC over B we get 75 over GJ, and angle PB over A we get 500 GJ. Angle PE over A equal angle PE over D plus angle PD over C plus angle PC over B and plus angle PB over A. So we get angle PE over A 855 over GJ. So we get 4 power C power of 4 216.55 exponent negative 9 meter. So we get C equal 21.57 millimeter. So we can get D with formula D equal to C. So we get D 43.14 millimeter. So we calculate the power given frequency F equal 3 Hz, torsion AB equal 100 Nm. So we get power 18.85 kilowatt. So D is calculation after modification. Given G equal 50 gigapascal, top mass equal 30 megapascal, and angle less than 1.0 degree. Torsion AB equal 500 Nm, torsion BC 200 Nm, torsion CD equal 150 Nm, and torsion DE equal 150 Nm. So we still use the same formula equation to get C power of 3. So we get C power of 3 equal 1.061 exponent negative 5 meter. So we can get C equal 21.97 millimeter. So we calculate angle PE over A equal 1.0 degree. Convert to radian, we get 70.45 exponent negative 3 radian. So we also calculate angle PE over D, we get 90 over GJ. Angle PD over C we get 16 over GJ. Angle PC over B we also get 16 over GJ, and angle B over A we also get 250 over GJ. So we get the calculation. Angle PE over A equal to 416 over GJ, and we can get C power of 4 equal 335.64 exponent negative 9 meter. So we can get C equal to 54.7 millimeter. So we can get D equal to 48.14 millimeter. So we calculate the power given the frequency equal 50 Hz, torsion AB equal 500 Nm. So we can get power equal to 55 kilowatt.
Hello, Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, I'm Muhammad Daniel. So I'm going to continue part of discussion for this project. So the goal set for this project is to increase or to maximize the power and torque that can be transmitted by transmission shaft itself. So based on the calculation that we have made, was proven that the shaft can only produce 18.85 kilowatt of power before we made a modification at the transmission shaft, and by right after we made a modification already, we get a positive results, which mean from 18.85 kilowatt increases to 25 kilowatt. Therefore, the larger the diameter, the more power that can be obtained actually. So the material of the shaft also play an important part in ensuring that transmission can perform as well as feasible. So, thank you. For the result, table 1 show that value of allowable power before we made modification and after we made modification. As you can see, that show at column 1 the allowable power before made modification, which is we using a 43.14 millimeter diameter shaft. It's only consume 18.85 kilowatt of power. Next column is the value after we made modification, when we using 48.14 millimeter diameter of shaft was consumed 25 kilowatt of power. Thank you.
Assalamualaikum and very good day. My name is Muhammad Arif Farhan, and today I will be presenting the conclusion for our group. So it's called conclusion. Shafts are used to sustain static, oscillating or rotating machine elements, although they do not generate angular momentum and are hence prone to flexion. On the other hand, drive shaft is a shaft that conveys torque and is sensitive to torsional stresses. This is the consequence of a couple's transmission, and it also may be exposed to other forms of mechanical stress. The usual shaft arrangement is a stepwise element with a circular cross section with a border cross section at the center to allow many elements to be placed on its ends, resulting in a higher section modulus in the central location where flexibility generates more stresses. So after doing analysis of the shaft, our group members able to achieve the objective of this experiment, and it is proof that when the size of diameter of shaft has increased, it can withstand more external load or force up. The torque of the shaft needs to be considered when improving its design, as the torque must decrease to get the larger diameter, and it is also important to create a new modification to build a new model shaft. So that's all from me. Thank you.